Welcome to the second lecture on Standard ML. In this we will describe the Standard ML programming model in a very brief sense. It's good to have this model in picture so that you can understand how programming goes. Okay. So what do we mean by programming model? The mental model of what programs are and what they do. Okay. That's the idea of what programming model is. Just to get an idea of a programming model that you know already, you have the C programming model, okay, which kind of you might have seen in the first year course. So what is that? Basically C has C programs have a set of variables. This is what I'm loosely, which are memory cells and assignment statements. Update these cells. The programs are essentially such statements, and computation happens by running these statements in sequence. Okay. So a programming model need not be the way in which it is implemented. Okay, this need not be the way in which the language really implemented. Okay. So it is important to have this mental model, which might be different from the actual implementation model, because the mental model is simpler for humans to understand. The model which is used to implement it would be the processor or something like that, which is complicated to understand. So it is good to have this model. So what is the SML model? Programming. So just like C programs consist of assignments, SML programs consist of programs are variable bindings. Okay. So what are variable bindings? We kind of saw it previously. Something like this: val, this is a keyword, x, which is a variable, to 10. Okay. So this is a variable binding, and it binds x to the value 10. Okay. Let's take something slightly more complicated. Val y equal to x plus 2. Okay. So here we see one important concept. It evaluates x plus 2 and binds to y. Okay. So in general, binding will look like a general binding looks like val some variable equal to expression. Okay. Okay. So which is this expression is what is evaluated and assigned to variable. Okay. Fine. And so programs are variable bindings, and computations, that is the next important thing. computations happen when expressions are evaluated. Okay. So what do I mean by expressions being evaluated? So what are expressions first? Example of expressions. For example, 2 is an expression, 3 plus 100 is an expression. Okay. So it's a variable something like x, or something like hello, something like print. These are all expressions. Okay. And some of these expressions are values. A subset of expressions are designated values. Okay. And are considered in their simplest form, sometimes called normal form. Okay. Anything that is not a value needs evaluation. It's not a value, needs simplification, sometimes called reduction. Okay. So let's look at these 2 points. Okay. Okay. So how does simplification look like? Let's say we have an expression like 3 plus 10 times 2. I am bracketing it so that you understand how the values are evaluated. So this kind of reduces to so you simplify this, right? So 3 plus 10 times 2 is 20, which further reduces to 23, which is a value. Okay, this is a reduction. Okay, this is a reduction or simplification. Okay, what happens when we have a variable like x? In that case, we need to look up at that point what is the value bound to x, and that is the value that is returned. Okay. So what we said is, let's go back here. Let's look at this example. Okay, so while z equal to x plus y. Okay, let's look at this example. How does this evaluation happen? Okay, so let's just run this code. Yeah, so you see x gets bound to 10, y gets bound to 12, which is a reduced form of x plus 2, and z gets bound to 22. Okay. Yeah, so how do you look at this? So when so let's commentary. Okay. Okay, val x equal to 10. So this is, let's look at how this goes. Commentary is following. 1, 10 is itself value, so no reduction. and then x gets bound to 10. Now let's look at y equal to x plus 2. Okay, so that's the next step. So here RHS is x plus 2, which reduces. I will use this figure to define reduces to, which reduces to. Okay, so now we have x. We need to find the value of x. Well, how do we look at it? At this point, let's find out what x is bound to. X is bound to 10. So we evaluate this to 10 plus 2, which further reduces to 12. Good. Then y gets bound to 12. Now let's look at val z equal to x plus y. Okay, so RHS is x plus y, which reduces to, let's substitute the value of x here, 10 plus y, again substitute the value of y, which is 10 plus 12, okay, and this gives us, this reduces to 22, so then z gets bound to 24. Yeah. So the point is, when variables are encountered, so essentially when variables are encountered, during evaluation, the corresponding value is substituted for it. Alright, and the evaluation process continues. So this is what evaluation, this is how evaluation happens. Okay. Yeah, so this is how evaluation happens. Let's put it here. Okay, this is how evaluation happens, and the rest is like if you see plus, then you add them up and things like that. Okay. So this is how computations happen in standard ML, and programs essentially are bindings. Okay. How a variable, so this what we have seen here is just one way in which variables get bound. Okay, there are other ways in which variables get bound. We will see that later on. But essentially, programs are just bindings. So let's summarize. SML programs are just bindings. Okay. So